Hello and welcome to today's VMware webcast. Before we get started, there are a couple of housekeeping items that I would like to go over. First, we want to make this session as interactive as possible and encourage you to ask questions at any time using the question and answer box located to the left of the slides window. You can also use the question and answer box to get technical assistance if you should need it. The tabs located in the question and answer box are where you can find additional information about today's presentation. Today's presentation features streaming audio only, so there's no need to dial into a teleconference. You'll need to make sure that your computer speakers are turned up in order to hear the presenter and today's content. You can also fine-tune the audio by using the volume controls inside the media window. This presentation console allows you to interact and customize the layout to fit your viewing needs. You can collapse and expand any window on the console just like you would on your desktop by dragging the corners in or out. In addition, you can also maximize or close any of the windows on your screen by clicking the corresponding icon in the upper right-hand corner of each of the windows. At any time, you can reset the console to the default layout and access additional presentation functionality using the widgets at the bottom of your screen. Now I'd like to turn things over to today's presenter to get things started.
Hi, everyone, and thanks for joining. Today's session is going to be on accelerating your hybrid cloud migration with VMware Cloud and AWS. My name is Jeremiah McGee. I'm a Senior Technical Marketing Architect with VMware. And my co-presenter is Arti Raju, Principal Solutions Architect with AWS. So let's talk about, cloud building challenges, right? So migrating workloads is not as easy as some people say it is. You're dealing with multiple VM formats. It's not a matter of, converting a VMDK into an AWS AMI file, but it's all about operational consistency and trying to leverage the skill sets and the tools that you already have. Provisioning is typically different in public clouds than in your on-premises data center. Tool sets are inconsistent between on-premises and public cloud. So think about the skill set needed to manage the migration process and the day-to-day operations. Think about different security baselines. How are you going to secure your applications in public cloud, and what tools or what tool sets are used for identity management? The kicker here is that traditional applications running in enterprises are typically stateful applications running on a resilient infrastructure which leverages HA, DRS, and all goodness offered by vSphere. Now compare this to public cloud where you get a very different set of SLAs from the infrastructure point of view. It's almost like invisible infrastructure that you have to rebuild your application to become stateless and incorporate resiliency within the application cause the infrastructure is expected to fail without guarantee that the data is available. Services like auto-scaling and automatic load balancing are at your disposal, but we see a lot of customers struggling with refactoring their application to leverage these services or transforming the application architecture to get it working with the cloud. So this is where VMware Cloud and AWS comes in. We're introducing two powerful forces coming together, so VMware with AWS. We thought long and hard about this and decided that if we partner with Amazon, we can solve all of these challenges. AWS is a renowned data center operator. It knows how to operate at scale, has global reach. Couple that with VMware, and you start to build scalable solutions in the cloud anywhere in the world that your skill set, and use your current skill set and your current tool set. So what is VMware Cloud on AWS? Well, VMware Cloud on AWS is powered by VMware Cloud Foundation, unified SDDC platform that integrates vSphere, vSAN, and NSX and provides access to a broad range of AWS services. Together with the functionality, elasticity, and security customers have come to expect from the AWS cloud. VMware Cloud and AWS leverages bare metal cloud services from AWS. These are dedicated bare metal servers that provide the basis for the vSphere software-defined data center. So with this, we have, if we look at the diagram here, we have on the left side, we have your operational management of your on-premises data center. And on the right side, we have AWS native services like EC2, S3, RDS, things like that. In the middle is where we come together. So VMware Cloud and AWS is sitting on again, on bare metal hardware. We have our full SDC stack, and it allows you to kind of interface between on-premises and the cloud and your AWS native services. This gives you full hybridity back and forth between the entire stack. So leveraging AWS and multiple global regions is really huge here. I mean, AWS has this entire global reach, and we've listened to our customers and our partners, and now you can see where we have services at. We are taking advantage of all of this, so you can see where we're at today, all the different availability zones, and then we have our roadmap published. You can see where we're going to be at in March, in Q2, in Q3, in Q4, and beyond. And as AWS extends, so does VMware in this global rollout path to make sure that we can accelerate and move your workloads into any region, anywhere in the world that you may need them. So deploying physical resources, the idea is to deploy them as fast as you can deploy virtual machines. And that's typically a tall order. With traditional infrastructure, you have to order hardware, you have to, procure it, deploy it. This could take days, weeks, months. And it's just not simply fast enough in order to scale with your current applications. So on premises, from our customers, we've talked to the customers, and we've kind of figured out there's an average time, right? From the time it was requested, your hardware for your servers, whatever you need them for, until you can actually consume those resources is typically 86 days. Sometimes that's less, sometimes that's more, depending on the infrastructure and the policies at hand. With VMware Cloud and AWS, once you have your initial cluster built, which takes about 2 hours, all hosts after that take about 10 minutes. So from the time you request a new host until your host is ready and those resources are ready for consumption, it's about 10 minutes overall. So there's various use cases we can take advantage of here. And for speaking with customers, agility is one of the main drivers for adopting a cloud platform. Whether it's private, public, or a combination of the two, with a hybrid environment, we see many different ways customers are looking to leverage this hybrid environment. Some customers really plan to keep the center of their mass in the private cloud, in their data center, but selectively looking to extend to public cloud for things like DR, geo capacity expansion, et cetera. Other customers want to reduce their data center footprint and run more workloads in the public cloud, sometimes migrating apps selectively, in other cases pursuing the data center zero model, and they want to get out of managing data centers entirely. Finally, we see customers who want to treat their private cloud and the public cloud as equal peers and easily move workloads between them for things like apps, moving apps from dev test to production, burst capacity, things like that. So we can see here, we have our use cases of cloud migration, moving and consolidating, data center extension, and disaster recovery. And all of these options are very viable with this solution. So let's talk about hybrid connectivity and workload mobility. So the first thing we want to talk about with hybridity is, taking advantage of on-premises. And what does that look like from an operational standpoint? So VMware Cloud and AWS is designed to provide you with a single pane of glass for hybrid cloud management. One of the new features we have is hybrid linked mode. And if you're a vSphere shop, you're familiar with linked mode. Hybrid linked mode is a feature that allows us to be operationally consistent between your vSphere environments, whether it's on-premises or in the cloud. And so what this allows us to do is, you can log into the environment and see both under a single pane of glass. If you have multiple vCenters on-premises in the same SSO domain, you will be able to see all of them in addition to your in-cloud vCenter resources. So it's really nice to have, to kind of see all that from an operation standpoint, as well as, other use cases like migrations and, overall day-to-day usage from the administrator. So what's really key here, especially with hybrid linked mode, is this notion of workload mobility. And so the idea here is to be able to take VMs and move them back and forth from on-premises to cloud and from cloud back to on-premises. And hybrid link mode really makes this a reality. So after it's configured, with some firewall rules and some other things, now we can leverage moving these VMs back and forth. And so we really have three ways that we can move these workloads back and forth. The first is VMware HCX, or hybrid cloud extension. The second is live migration, and the third is a cold migration. So our live migration is a vMotion. Our cold migration is just a vMotion of a powered off VM. We also have, from a workload mobility standpoint, you need to be able to provision workloads in the cloud. That's where content libraries come into play. And so you have your ISOs and your templates and your OVF files all sitting out, in your data center on premises, and you need to get them out there. So, we can actually take and build content libraries in VMware Cloud and AWS and subscribe to your on-premises content library and pull that in. So now you can easily deploy your same templates, your same images in the cloud, that you would on-prem, and you don't have to worry about, there being, different versions strewn about and things like that. And then lastly, we have enhanced vMotion capability, and this is really key for moving those workloads, because we're going to have dissimilar hardware on the cloud side. And so being able to move these VMs and take advantage of per VM EVC is really crucial, as opposed to doing it on a cluster level. It just makes it more seamless and easier to move those workloads back and forth. So how do we get our applications to the cloud SDDC? The first thing you want to think about is, what can I take from a business perspective, an application perspective? What kind of downtime can I take? Can the VMs have downtime? Maybe they're dev test, maybe they're really low end or low tier applications that don't get used very often. Things that can take downtime. Other things, maybe they'll take minimal downtime. They're not mission critical applications, but they're still pretty widely used. You can, usually get a maintenance window for them. And then VMs that are your mission critical, you can't take downtime on them. They have to be live, and so we have to kind of figure out, what does that look like from your perspective? So you want to categorize those, bucketize those, and then make sure we move those, accordingly and label them accordingly. So we'll label them as VMs that can take downtime, VMs that can take minimal downtime, and VMs that can take no downtime. Once you have that organized and sorted out, then we can figure out what the migration paths are for those workloads. And so when we want to look at moving those, we think about the downtime, and if there's downtime that can be taken, maybe a cold migration is the easiest. That, we can shut down the VM, we can migrate it over, there's no issue with the data or the length of time to move that VM, especially if it has a lot of memory, things like that. And then we have to look at other things too, like what sort of standard switches or distributed switches using. Do we have an IPsec VPN and firewall configured appropriately? If we need to vMotion it and needs to be a live vMotion, do we meet the criteria there as well? Do we have the right distributed switching? Do we have the right, network connectivity? Are we using a direct connect? Do we have our firewalls configured? There's a lot of different things that we need to think about there. But, where the next item comes in is VMware HCX. So this kind of takes the guesswork out of some of that. And especially if you can have low downtime, HCX is a great option as well, because we can do replication assisted vMotion, where we're replicating the VM over to the cloud side, and then we can designate a failover, a cutover, or a live migration over direct connect with HCX. So we can kind of figure out, what do we want to do, how do we want to do it. In the case of HCX, you may want to do bulk migrations or a scheduled migration, and so that gives you a little bit of leverage and some extra options in terms of your migration strategy. So if we talk about HCX for a minute, large scale simplified workload mobility. And the really cool thing about this is, as long as your on-premises environment is at least vSphere 5.0, which hopefully it's not, but, anywhere from 5.0 to 6.7 you can have on-premises. You can have standard switches, distributed switches, Cisco Nexus 1000V. HCX really looks at all of that information and allows you to move those workloads to the cloud, whereas you may not have been able to previously. You wouldn't be able to vMotion a VM from a 5.0 environment to a 6.5 environment or a 6.7 environment, and the same is true of migrating those workloads to VMware Cloud on AWS. And so we do a lot of things with this. We do Lan Optimization, we can do bi-directional migrations, we require very little network bandwidth. We can do it over internet with VPN or direct connect for both bulk migrations and vMotion. And the cool thing about this is once you set it up, we can just schedule all of our workloads to move seamlessly. So you say, hey, this is my app stack. I've got, a dozen VMs in a particular app stack. We can bulk those together, tell it to replicate over, designate that we want to fill this over at, say, 3 a.m. on Saturday morning, and then let it go, and it will move everything for you. And the best part is it's included with VMware Cloud on AWS. So the integration point is key here. So a hybrid cloud extension is an add-on. You simply go in, you enable the add-on, it deploys the management VMs into your SDDC, and then it provides you with download links and information to deploy the on-prem components. Once they're deployed and configured, you're in business to start migrating VMs. So aside from HCX, we have our vMotion or our live migration. This is key with hybrid link mode. Your VMs need to stay powered on. It requires a little more bandwidth. You got to be careful of your round trip time, so your latency. This is similar to a long distance vMotion, so those caveats apply. But you got to make sure your networking is in order. Your direct connect, your distributed switches, your VPN, your firewall rules, all of that. But then certainly you can just right-click a VM, and it's simple as saying migrate and letting that VM vMotion over, and you're in business. Now, the key here is, let's make sure we have our networks available and things like that, but largely the vMotion works really, really well. And finally, our cold migration, right? So these VMs can take downtime. It's no big deal. Maybe you've got a bunch of VMs that are already powered off. Maybe they're dev test. Maybe they're whatever the use case is, or maybe they're powered on, but you can take downtime. We can shut them down, migrate them over quickly, and bring them back up on the cloud side. So I'm going to hand it over to Artie to talk about native AWS integration.
Thank you. Jeremiah talked about some of the migration phases that customers go through. And what we are seeing from customers is once they've migrated either using a live vMotion or HCX, customers also want to integrate with their native AWS environments that they're running. And what we'll focus for the next couple of minutes is how VMware and AWS have engineered together to deliver this for us customers. We know that the VMware Cloud on AWS has its own account. So if you look at this picture here on the left, you see the VMware Cloud on AWS SDDC account. So this will be the account that as customers, when you sign up for the service, VMware will spin a new account for you and then have your ESXi host, the bare metal instances, running in this account. What's available to you as customers is you have access to create your logical networks and deploy your VMs on these networks. You don't get access into the account itself, but you get your vCenter access. What we wanted to do for our customers is customers told us, hey, I already have AWS services that I'm running in my account. How do I integrate both these, right? Because they want the best of both worlds. So as part of our engineering efforts when we were launching this service, we said, okay, we want to provide customers a faster, low throughput, high bandwidth access so that VMs running inside their SDDC can access resources inside their VPC or inside their AWS account. And the way that we are doing this is using elastic network interfaces. So on the right side, you see a customer-owned AWS account. So as part of the onboarding process, VMware assumes a role inside the customer's AWS account once customers grant permission for specific activities. And one of them is creating these network interfaces. So you see in VPC Subnet 1, you have 4 network interfaces. So as part of the process, these network interfaces are created, and these are directly attached to the ESXi host running inside the SDDC account. So basically, these ENIs are attached to the i3 metal or R5 metal instances running inside your SCDC cluster. So if you think about this, what this allows you to do as a customer is now you have this direct network private path between both these environments. Think of a native AWS environment. If you own multiple accounts, this is not possible. So this is some engineering work that we had to do on our side to enable this for customers. So once the ENIs are created and attached to these hosts, you now have this private backbone connectivity. So if you have, let's assume I have a Redshift cluster, which is our data warehousing service inside the customer account, and this needs to communicate to one of the VMs running inside the SCDC. All it needs to do is the route table, the main route table is updated by VMware automatically. So any of your logical networks will have a route from your VPC. So it can use this ENI path to communicate to your NSX T0 router, which knows how to then send that traffic to the particular VM that you need. One thing that we have to note here is like, what if your host fails, right? Let's say the NSX T0 router that's running on host 1 fails. We don't want our customers to end up in a situation where like during host failures, you have a disruption to your data flow traffic. So what we've done is when there's a host failure, the T0 router, the NSX T0 router that you see here is moved on to another host. And what's important on the customer side is the route tables are also updated to point towards the new Elastic Network interface. So keep in mind that at any time one ENI is active, so that gets and sends all your traffic. So in case the host fails, the corresponding ENI is taken out of service and the route tables are updated to go to the new ENI. So if you think about this, when there's a host failure, I still once my ENI is transitioned to the new ENI, I still have routes from the customer VPC to the SCDC. So this allows customers to have that private backbone connectivity, like high throughput, low latency path between their environments, their SCDC environment and their AWS environment. If you think about what this enables us to do, right, there's a lot of interesting use cases that we are seeing. We initially thought about storage as one of our interesting use cases, but as we started working with customers for the past several months, we're seeing interesting use cases from our customers utilizing this specific feature that we've introduced for them. We talked about S3. So S3 is our simple storage service. It is an object store that AWS provides. And what VMware has done is on the right side, you have your SCDC environment here, and on the left is my customer managed VPC, and we see that ENI connectivity. On your VMC console, when you enable S3 access, what happens is any traffic that you, let's assume it's backup traffic or any traffic that you want to send to an S3 bucket in the same region, it uses this ENI connectivity path and then sends it to an S3 VPC endpoint, and all this traffic stays within the AWS backbone network. So all of this traffic is private traffic. We also recommend this for most customers who have VPC endpoints for S3 configured. And when you transfer data in and out of S3 in the same region, it is actually free of cost. There is no cost involved. There are also some customers who don't use VPC endpoints for specific use cases, and they want to use the internet gateway. And this is also possible. So you would have to disable your S3 access on your VMC console. So once that's done, what it does is it uses the internet gateway associated with the SCDC VPC to reach out to S3. So S3 is a very common use case that we get here from customers for backup purposes or DR purposes. We want to back up a lot of our data into S3, and S3 is cheap as well. So we see customers using S3 for various use cases. There's also other services that we are starting to see customers use. AWS Private Link is a feature that allows customers to access services hosted on AWS easily and securely by keeping their network traffic within the AWS network. So any services that are supported by the private link will be supported with VMware Cloud on AWS offering as well. If you want to drill down into a specific example, we have the SCDC here, and let's say I have a MySQL or a SQL Server database that I'm running on AWS Relational Database Service. Think about a web application. I still have my web front ends in my SCDC, but I have my database running inside AWS. And RDS is a managed service, so customers don't have to worry about patching, upgrading, things like that. So if you think about accessing RDS for customers, this ENI connectivity provides them a way for their VMs to access their database using this high throughput, low latency link. And having RDS close to your SCDC is great because now think about like round trip time or latency with this high throughput, low latency link, you're going to see like really good performance. Another common use case that we see from customers is using Elastic File System. So the same network path works for the EFS as well. If you kind of put everything together in terms of service integration, we see customers who start with simple web applications. They could have their web applications running inside their VMware SCDC. So if you look at this diagram here, I still have all my VMs that I'm running inside my compute network. I'm not making any significant changes to my architecture. But what AWS does is it allows customers with this integration that we talked about, it allows them to add value-add services such as the application load balancer. The application load balancer supports IP target group. What that means is I could have an application load balancer in my account and then have my VMs as a backend using IP target groups attached to this application load balancer. So if you think about it, I can have a direct application load balancing scheme implemented. So users coming to my website can hit my application load balancer, which then distributes traffic to the VMs. What this also comes with is additional services. If customers are looking to do web application firewall, the application load balancer is heavily integrated with AWS's web application firewall. And also our AWS Shield, which is our DDoS mitigation service. So from a security perspective, if you look at this architecture, I'm not actually changing anything to my stack that I'm running on the VMware Cloud on AWS, but I'm using additional services not only to protect my workloads, but also think about load balancing feature or think about additional features such as the web application firewall that I can use from a security perspective. So these are some of the common use cases that we are seeing from customers. There's additional use cases that we see with other AWS services as well. We talked about some of the service integrations that are possible today, and we're also exploring additional service integrations. What we're also seeing is, apart from specific service integrations, we're seeing customers looking at migrating specific workloads into VMware Cloud on AWS. And some of these are typical enterprise applications that we see from our enterprise customers. The first one is Oracle. For customers who've been using Oracle RAC on-prem, it has been always a challenge to migrate this to AWS natively because AWS today does not support specific features such as multicast or shared storage. With VMware Cloud on AWS, given that it is possible, it provides customers a seamless way to migrate their Oracle applications that they're running on-prem into the cloud in a couple of ways. Jeremy talked about some of the live vMotion and HCX that allows customers to migrate VMs from their on-prem, and this is similar with Oracle workloads as well. And this also allows them to migrate these applications faster into an environment and that they're already familiar with. A lot of questions around licensing comes around with Oracle when we talk about moving Oracle workloads into the cloud. We have a separate team, and we also have partners like House of Bricks and Palisade who validate licensing with Oracle. And I've also come to a conclusion that Oracle RAC on AWS is a solution that will run on VMC, and we're also starting to see customers move some of these Oracle workloads into the cloud. So if there's any questions around licensing, we'll be happy to dig into it, and we have partners that are certified to do this. The next use case that we see from an enterprise perspective is SQL Server. Testing that we've done, like VMware's done intensive testing on running SQL Server on on-prem versus VMware Cloud on AWS. And we are seeing significant, pretty much better performance running on VMware Cloud on AWS, given the dedicated bare metal instances that you get. It also scales really well, and given with stretch clusters, you have SDDC clusters that can span across availability zones. It provides you a very high availability. In case of an availability zone failure, you always have your SDDC running in the other availability zone with all your data, so there's no data loss. And this provides customers this high availability and scalability aspect that they're looking for their database workloads. What it also lets you do is utilize the other AWS services. You could integrate it with native services such as our AWS Managed AD that allows you to use Active Directory that you're already using on-prem with your SQL Server workloads. With that, it's a wrap to our migrations webinar today. What I want to call out as our call to action is on the Oracle workloads, we do have a deep dive webinar that's coming up on March 19th at 10 a.m. and we have the URL here. So feel free to go ahead and register. So this webinar will talk about some of how customers can migrate their Oracle applications, either it could be Oracle RAC or any other applications, into VMware Cloud on AWS, and we'll also touch upon the licensing aspects. If you want to go try this out, VMware Cloud on AWS has a single node offering that you could go deploy, and it's valid only for 30 days. So go ahead, try the single node offering, and you can play with the platform to test it out. And also, for example, do things like the live vMotion, set up a VPN connection or set up HCX from your environment to your on-prem, and try migrating workloads to see how easy and flexible it is to do this. With this, it's a wrap, but if you have any questions, feel free to post it in the chat and we'll be happy to get back to you. Thank you again for joining today.
Thank you once again for joining us for today's webinar. I'm going to go through some of the questions that we received on the chat, and I'll be answering. We've tried to answer most of them on the chat, but if there's something we missed, feel free to update the chat, and we'll be happy to answer. Some of the questions that we received around, especially around the connectivity piece between AWS and the VMware SDDC are, what are the prerequisites for connecting and VMware SDDC to AWS? So the couple of prerequisites are you need to have an AWS account. So when you create a VMware SDDC, it will ask you which AWS account do you want to connect to. So this way you will have to have an AWS account that's pre-created. The other pre-requirement is you'll have to have a virtual private cloud, a VPC, already in your account. Most newer accounts of AWS will have a default VPC, so you could use this. Or if you already have workloads running in a custom VPC, you could use that particular VPC. The other questions around connectivity that we received were, what are the data transfer charges? Are there any data transfer charges when you transfer data between your VMware SDDC and your AWS VPC? So this follows the standard AWS data transfer pricing. So if you are communicating from an availability zone, if both availability zones are same across your SDDC and your AWS VPC, then there's no data transfer charges. But if you're communicating across availability zones, then there is a data transfer charges. And we'll put in the link to the pricing on the chat. The other question was around how quick are the connections between the SDDC services to the AWS VPC. Think about this as any connections or any requests that you make between, let's say you have two EC2 instances in your VPC. It follows the same principle. So this is not something that's located outside or in our co-location, right? This is within the AWS's data center. So any benchmarking that you've done within your AWS VPC, you would see the same throughput and latency for your SDDC as well. And then we had another question around how is the connectivity set up between the AWS SDDC, the VMware SDDC, and the AWS account. So when you as a customer onboard for the service, there is a CloudFormation template that you will need to run. And once the CloudFormation template is run, it will automatically set up, create these VNIs and connect them to your SDDC cluster. So you don't have to actually go in and manually spin up any elastic network interfaces. VMware also takes care of updating the route tables for you. Another question is around the hypervisor. Do we use nested? We don't. So this is AWS offers VMware the bare metal instances that we've launched recently. So these i3 metals and R5 metals are our bare metal instances. So these bare metal instances are given to VMware, and then VMware uses ESXi. So this is not any like nested or word-on-word virtualization. So there's a question on how do we configure VMware Cloud to use all AWS services, and if we will have any webinars relating to this. We sure will have webinars focused on native AWS connectivity and service integrations. But in general, think about integrating with any AWS services. If the AWS services has a private endpoint using private link or gateway type or interface type endpoints, then you should be able to access it from your SCDC endpoints. So there's questions around implementation designs with HCX. HCX is included as part of the offering, so there's no additional cost of using HCX. And we've got some design docs on our online website on how to actually implement HCX with VMware Cloud on AWS. Okay, I think we've answered pretty much most of the questions that are on chat. Apologies if we've missed any. I would go through the list again and answer back on chat if we've missed. But thank you so much for taking your time on a Tuesday and joining us. Hope to see you guys in the next webinar. Thank you.